Okay. Okay, so he spins a lasso perpendicular to the ground. So there's the ground. He's spinning a lasso whose line of symmetry is perpendicular to the ground. Okay, so that's what we know. The height of the knot from the ground. Where's the knot? Is that up there? Not being a cowboy, I don't know how to where you. No, the knot's got to be right in this side. Correct?
I think you had it right the first time. Because the knot's at like the edge of the lasso.
Really?
Yeah.
So
Because that's how.
if you had a lasso and you were spinning it, the knot would be on the edge? Okay.
Yeah.
Like I said, not being a cowboy, I'll leave it like that. Hold on 1 second. All right. So the height, which is this distance from here to there. Although I'm still not sure of that, but we're going to assume that. May not make any difference whether our picture is accurate or not, because what we have is an equation right there, where the only variable in that equation is the height and time.
Okay.
So let's just take every question one at a time. What's the highest point of the knot? Doesn't really matter whether my picture is correct or not. The highest point of the knot comes when that is equal to what? Do you want it equal to 1? Do you want it equal to -1? Or do you want it equal to 0?
1.
Nope, because it's being multiplied by a -3. So if that thing is equal to 1, it's going to subtract from the height of the knot. If it's equal to 0, it's going to have no effect, and then the height of the knot will be 3.5. But what if it were equal to -1? In other words, what if cosine of 5 pi over 3 times t happened to be equal to -1? Would that not give you the highest point? Remember that cosine only goes from -1 to +1.
Right.
So if I want this part of it to be a maximum, then I want cosine to be -1. Because -1 times -3 is +3, and my height would be 6.5, which is the highest possible height for the knot. And in fact, it has nothing to do with our picture so far. Is all I'm trying to do is get the cosine of 5 pi over 3 times t to be equal to -1.
Okay.
Okay, so you really kind of have to understand your cosine curve here. This is why this is one of the most important things you can remember. That's 1. That's minus 1. That comes at pi. So we're looking for this point right there, which means the inside of the parentheses, 5 pi over 3 times t, we want that to be equal to pi, because the cosine of pi is minus 1.
Okay.
And minus 1 will make that total plus 3. Added to 3.5 will give you a total of 6.5. There's no way that rope is getting higher than 6.5. Okay?
All right.
Now, we've got to solve that. We've narrowed it down to 5 pi over 3 times t equals pi. Let's solve that equation.
Okay.
How do you solve that equation for t? You're looking for your last line to be that. What's the first thing you can do?
Multiply by 3.
Okay. What's the second thing you can do?
Divide by 5.
How about divide by pi? Get rid of that.
Okay.
So now you have 5t equals 3. So what does t equal?
3/5.
That's how many seconds would elapse. In other words, they want to know what is the highest point. They want to know what the highest point reached by the knot. Well, we just figured out at what time that would occur. So what is that height? That's not really what they wanted. It's just something we had to figure out first. Was at what time would the knot be at the highest point? So now what do we have to do? We go back to our original equation and we substitute what to figure out what h is actually going to be. Remember, there's two things in this equation. There's the time that it occurs, and h, that's the height. Well, the question says, what's the highest point? Well, we know it occurs when t equals 3/5.
Okay.
So we get the height is equal to minus 3 times the cosine of 5 pi over 3 times 3/5. How convenient. Notice why. Plus 3.5. Well, that 3 cancels with that 3. That 5 cancels with that 5. What's the cosine of pi?
1.
Look at this right there. What's cosine of pi?
Oh, -1.
Okay. Makes a big difference. In fact, that's probably the biggest mistake made in all of math, is getting the sign wrong. And if you get the sign wrong, you're getting the problem wrong. The sign is every bit as important as the number. Okay?
Okay.
Have to have the sign right. If you get it wrong, you're going to lose all points on that program or on that problem. Okay, so what we have is minus 3. Cosine of pi was minus 1 plus 3.5. What does that answer?
6.5.
Yeah, so that's what the answer to the first one is, 6.5.
Okay.
Second one, what's the lowest point reached by the knot? Well, what does that need to be for the lowest point? Oh, excuse me, hold on. Don't say anything yet, because I kind of misled you. What does this need to be for the lowest point? What is the cosine of 5 pi over 3 times t have to be to make the height the lowest it could possibly go?
1.
Correct? Well, where does that occur on the cosine curve? Right there. So when this is equal to 0, so 5 pi over 3 times t has to equal to 0. So what's the answer? What's t equal to? Solve that equation right there. Remember, when you have two numbers multiplied together that are equal to 0, one of those numbers has to be 0. That is not a variable. That is a number. So the only variable is t.
So 0.
Yeah. So we're going to plug in 0 for t. What do we get for the height? We get height equals minus 3 cosine of 0 plus 3.5. Well, the cosine of 0 is 1, right? Right.
Yep.
So that's minus 3 plus 3.5. That's going to be the lowest point. 0.5. So the answer to that is 0.5. The answer to the first one is 6.5. Now,
Okay.
let's look at C. Man, they are hitting you with some hard ones here. These truly are the hardest trig problems, without a doubt. For me as a tutor and for every student that I've ever known. It's when you have these periodic, and this is actually one reason why trig is so important. Because you're answering really important questions here about life. In other words, when you have real life problems, it's what's the highest point on the loop? What's the lowest point on the loop? What's the period of the model? Now, all you have to do is take that. If you remember that y equals a sine of b times x minus c plus d, you've seen that?
Yep.
Well, b is 2 pi over the period, which makes the period 2 pi over b.
Right.
In this case, what is b? What's a?
3.
What's b?
1.
What's this? That's a number.
Oh.
Don't see pi and think it's a variable. Pi is not a variable. Pi is a number. So when you have 5 pi over 3, you have a number. That's b. So the period equals 2 pi divided by b, which is 5 pi over 3. You better be good with your algebra here, because you're always going to be dividing by fractions. Okay? So what's that answer right there?
So
we're going to turn it into a multiplication problem. How do we do that?
right. Flip the bottom over, so it's 3 over 5 pi.
Now, good things happen. Pi's cancel, and you end up with 6/5. That is the period.
Okay.
Okay, but you definitely have to know all of this. This is probably the single biggest reason why they treat sinusoid functions differently than polynomials. Because when you have a polynomial, b is merely a horizontal stretch or shrink factor. But when you're talking about a sinusoid function, whether it's a sine function or a cosine function, b is equal to 2 pi over the period. Remember that. That is the most important thing you can remember in terms of the differences between sinusoid functions and polynomial functions. You have to be able to translate between b and the period. The period is what we always want. Okay?
Okay.
If I'm on a rope swing, swinging out over a lake or a river, the period is the time between I hop on the swing and between the time I get back to that same point. That's always the period. Okay? And this, I cannot stress how important that is. You have to memorize that. Okay. That's the main difference between polynomial transformations and sinusoidal transformations. All right, so according to the model, find the height of the knot after 25 seconds. What am I going to do here?
Put 25 in for t.
Okay. Height of the knot. Now, t is measured in seconds. Okay, that's good. 25 seconds. Whoops. There we go. Whatever number your calculator gives you. Okay. Now, the reason I say that is because this part here is obviously 125 pi over 3. That's an irrational number. So you're going to have to get the cosine of that out of your calculator every time. Then you're going to have to multiply it by -3. And then you're going to have to add 3.5. And that will tell you the exact height of the knot at any point in time. You just have to multiply that 5 pi over 3 times whatever time they're talking about. I put a dot there. I didn't mean to. Once I put parentheses around it, I don't need the dot. We're multiplying by 25.
Okay.
What do you get? You got your calculator in front of you?
Yeah.
Try that. I would start from the inside, take the cosine of 125 pi divided by 3. What do you get? What kind of calculator do you have?
It's a Casio.
in that case, there's only one calculator that I would suggest you start from the beginning, and that's the Inspire. But if you're using anything else, it's going to be hard to tell exactly what you're putting in. And so therefore, you start from the middle. Start from what is the cosine of 125 pi divided by 3? What does that equal to for starters?
Cosine of negative 0.65.
Multiply that by negative 3. This number right there.
So 1.96.
Now add to it 3.5, the rest of the equation.
5.46.
That's the height of the knot after 25 seconds. If I wanted the height of the knot after 26 seconds, I would merely plug 26 in for t.
Okay.
Okay. All right, let's go on. As I said, there is no tougher subject in trig than these.
Right.
In fact, I rarely find students that have problems this difficult in trig. You're obviously taking a trig course, not just trig as part of algebra 2, correct?
No, I'm just taking algebra 2.
You're kidding me. And they're giving you these kind of problems?
Yeah.
What school do you go to, Dimitri?
Pomona High School.
Wow. Like I said before, even when I have students who are taking a semester of trig, I don't always get these kind of problems. Okay? So these are hard. These are really hard. Don't get discouraged by them. The only thing you have to remember is the sinusoidal equation.
Okay.
Okay? This is tough stuff. And it's very unusual for you to get it as part of algebra 2. But we can certainly handle it. Okay, so always know what your standard equation looks like, because it matters in a lot of these questions. Okay?
Okay.
Now, A is the distance from the max. Let me think for a second. Minus the min all over 2. And D is the max plus the min all over 2. How did I figure that out? Well, I know A in my basic model is 1. Well, how would I get 1? I would take 1 minus a minus 1. I would get 2. I would divide it by 2. I would come up with 1. So that's how I figure, that's how my memory works, is I know that A is 1 in your basic equation, y equals sine x. Okay? So what does it have to be? It has to be the maximum minus the minimum. Whereas D in my basic equation is 0, right?
Right.
In other words, there's no vertical shift in my basic equation. So D is 0, and if I take the maximum plus the minimum, I get 0 divided by 2, that's 0. So that's how I memorize these two, by knowing what that thing looks like.
Okay.
Okay? So, they're giving us a lot of information here. They're giving us remember the real value of trig is that it models so many things in real life. Anything that's periodic. Well, when you have a leaf floating on water that's bobbing up and down, it's periodic. The height of that leaf is going to go like that, right?
Yeah.
Okay. So that's why trig is so special, because almost everything in life is periodic. You could talk about the seasons, you could talk about the temperature on any date in the year, you could talk about somebody breathing, you could talk about somebody swinging on a rope swing out over a river. All of those are periodic things. So, write a cosine function that models the movement. Well, here's the cosine function, but we have to figure out A, B, C, and D, and then we'll have the answer. Well,
Okay.
what's A? Maximum minus the minimum divided by 2.
So
What's the maximum minus the minimum? The distance between its highest point and its lowest point is 4 centimeters. What's the maximum minus the minimum?
so 4
Yes. Divided by 2
is 2.
equals 2. So we have solved for A. Oops, excuse me. Meant to write a 2. Okay, we haven't solved for B yet. We haven't solved for C. But as long as they're talking about it, let's solve for D. What's the maximum plus the minimum divided by 2?
So yeah, 5 then, because 10 divided by 2 is 5.
No, 10 seconds has to do with the period.
Oh,
Okay. First of all, if the maximum minus the minimum is 4, then that could be like 8 minus 4. Could also be 4 minus 0. Now it kind of matters because D is the maximum plus the minimum.
okay.
So if I had the maximum plus the minimum, it would matter whether it was that or that. Let me think about this for a second. So you got a leaf bobbing up and down like this, and that is the difference between that and that is 4, right? Difference
Right.
between the highest point and the lowest point. The leaf is right there. So the line of symmetry, we can't actually tell what that is, but if we were to place it like that, then it would go up to 2 and down to minus 2. That would be the 4.
Okay.
So I'm going to say that D is 2.
Okay.
Now, we're not even close to done yet. We'll check it after we're done and make sure that it makes sense. Now, here's the next key piece of information. It moves from its highest point down to its lowest point and back to its highest point every 10 seconds. Tell me what its period is.
10 seconds.
Okay.
Oh, yeah.
Well, what do we know? We know the period is equal to b divided by, 2 pi divided by b. Correct?
Right.
So if the period is 10, and that's equal to 2 pi over b, then b is equal to 2 pi over 10, which is pi over 5. So now I have b. So now I got 2 sine of pi over 5 times x minus c plus 2.
Okay.
Now, the only question is what is c? Well, c is the phase shift. In other words, if there is no phase shift, this thing starts right here. It bobs up, it bobs down, it bobs up, it bobs down, it bobs up. So the phase shift kind of depends on where it starts. Well, they haven't really given us any information at all about a phase shift. So the only thing we can, this is a terrible problem, but the only thing we can assume is that the phase shift is 0. So your final equation is this. Now, the next thing, remember that's the height.
Right.
So the question really becomes, does that equation fit everything they have told us? And remember something else, that you don't have just one sinusoid equation that defines an action. There's virtually an unlimited amount of them. In other words, I could add 2 pi to that pi over 5 so that I had 11 pi over 5, and I would get exactly the same answer. Okay? So there's lots of different equations that can work, and they don't all have to be sine. I could make a cosine equation with a phase shift that worked. The question is, does that work? Well, if we check A is definitely 4 divided by 2, so that's correct. B is definitely 2 pi divided by 10, so that's correct. And the only thing that's in question is that plus 2. And if you think about it, that could mean a lot of things. We could have a leaf bobbing like that, but we could also draw our line of symmetry up here and have the leaf bobbing like that, and it would produce the same information. In other words, the difference between the highest and the lowest point would still be 4, regardless of where it was at on that curve. So I'm not even sure that there is a D needed. There isn't. In other words, that's the answer. 2 sine of pi over 5x. Not x, actually, but t. When you really get into these sinusoid functions, you will realize that x is never x, it's always t. In other words, when you're talking about periodic stuff, like a leaf bobbing on water or a water wheel or whatever, it's always a function of time. Real life is a function of time. And it doesn't matter if I'm analyzing a Ferris wheel or somebody swinging out on a rope over a river, or somebody breathing, or the tides coming in and out, or the temperature on any given day of the year. They are all periodic. They just reproduce their cycle, whatever period. If you're talking about the temperature on the day of the year, then the period is 365 days. In other words, the most likely temperature on April 4th or April 10th next year is whatever it was on April 10th this year, because the seasons repeat the temperatures. All right. So that was even tricky. Even for a hard trig problem, that was tricky. It doesn't really give me confidence. They're not helping you by doing this. They just aren't. I'm sorry. These are just way too hard for Algebra 2. Even if you were taking a course, a full semester of trig, I would say you're in honors trig. Just based on these problems. So, I'm not sure how much help we're giving you here. In fact, let's look at 6. This is going to be far more useful to you. Mainly because they've showed you the graph. Okay? This is the kind of stuff you're going to need to be able to do. Not this stuff. I don't like criticizing teachers, but this is ridiculous. It really is. At least with number 6, we are looking at what kind of a curve? What curve is that?
Cosine or sine?
Sine. Absolutely, it's sine. Sine starts at 0 and it goes up to its maximum, then it goes down to its minimum, and then it comes back to 0. So the period is between there and there. Okay?
Right.
So start with the sinusoid function, and we can even say for sine for sure, because it's not cosine.
Stop.
Tell me what D is. How much vertical shift is there in the graph you're looking at as opposed to the normal sine curve?
There's none.
Okay, D is 0. That's why I asked it first. Now, remember what A is. A is the maximum minus the minimum divided by 2. Well, the maximum is 120. The minimum is minus 120. Do the math. Tell me what A is.
120.
So y equals 120 times the sine of B. We can see there's no phase shift, right?
Right.
Now what a phase shift does, it takes the normal parent curve and it moves it left or right. Well, if the normal parent curve is sine, that hasn't been moved left or right. So we know C is 0 also.
Right.
So the only thing really left to figure is B. In other words, this is our answer, except we got to figure out B. Well, B is equal to what?
1.
2 pi, I want the general
Oh, 2 pi over b, or period, and then it's
2 pi divided by the period. Well, let's figure out what the period is. It's pretty easy to figure out the period. You just have to figure out peak to peak or valley to valley or this point, the midpoint to the next midpoint. You could go from here to there. You could go from here to there. Very important that you understand how to figure the period. Okay?
yeah.
So, if I do the two most logical points, what is the period? What is it from here to there?
6 pi, I think that is.
That's a 60.
Oh, 60.
Yeah,
Oops.
not always in terms of pi. And in fact, in this case, it's going to be in terms of time. Okay, so this is going to be a t, time. But we've figured out that the period is 60 by just measuring it from the graph. So what is b?
60? Oh, wait. No, it's 2 pi over 60. So,
If I top and bottom by 2.
so it's 30. Pi over 30.
Pi over 30. Not 30, pi over 30. So
Right.
now we have everything. We have A, we have B, and it doesn't really matter whether we use a T or an X. We'll use an X just because they didn't tell us it was T, so we'll use X. Okay? But just understand that X is frequently, 90% of the time, it's a measurement of time. So there's the answer. And by looking at that graph, I could tell D had to be 0 because my line of symmetry goes through the x-axis. That's a D of 0. If my graph would have been up here, then I would have had to figure out where the line of symmetry was relative to the origin, and that's what D would be.
Okay.
Okay? So you can frequently look at a graph and know exactly what D is. It's 0 here. You can measure the period. Once you measure the period, you know what B is. B is in boy. A, pretty simple. Maximum minus minimum divided by 2. Phase shift is the distance that it would have to be moved right or left to get it to the original position that the sine curve would be at. In other words, let's take something like this. Normally, a sine curve looks like that, okay? Well, and that is pi over 2. That's pi. That's 3 pi over 2. That's 2 pi. So let's say I phase shifted that to the left by pi over 2. Well, what would that turn it into? I'm taking every point and I'm moving it to the left by pi over 2. That takes that green dot, puts it there, and now if I draw the curve, look what I got. I got a cosine curve.
Right.
That's fine. In other words, y equals sine of x is exactly the same as y equal cosine of x plus pi over 2. Those two are the same. One is just phase shifted over the other.
Okay.
An important concept to understand. In other words, every curve is a sine curve. You could call every curve a cosine curve, but the only difference between them is one is phase shifted over the other one. The cosine curve is phase shifted by pi over 2 to the left. Always. As opposed to the sine curve. So the answer to 6 is that. Let's go back and look at 5. This is one, if you have to turn this in or something, you're going to want to rewatch this video.
Okay.
Just because.
All right.
Because these are so hard. A water wheel is 14 feet in diameter. Rotates 3 revs per minute. The center of the wheel is 6 feet above the water, which it draws. So we have a water line right there that's at 8 feet. We're going to put an axis on this thing. That's what it would look like, kind of. Okay? In other words, its diameter is still 14 feet. It operates at 3 revolutions per minute. What's that going to allow us to figure out? The period, right? Remember what the period is. That's the point that point makes 1 complete revolution and gets back to the same point. So they're saying that is this water wheel turns 3 complete times every minute.
Okay.
Okay, we're going to be able to figure out the period from that. All of these other dimensions are going to help. Man, this is going to, I don't even know the point of going over this problem, to be honest with you. But we can. This is as hard as it gets. Okay. Okay, so write the sinusoid function that models this water wheel.
Okay.
Well, let's start with A. What's the maximum height? Remember, this is the water.
Right. So
This is the ground. When I say maximum height, I mean, what's that height there? What's the diameter of the water wheel?
So it's 14 feet.
Okay. Now, B is 2 pi over the period. Well, if I make 3 revolutions per minute, what is my period?
So
How long does it take to make 1 revolution? If I'm making 3 revolutions per minute, that's 3 revolutions per 60 seconds. How long does it take to make 1 revolution?
20 seconds.
Okay. Only instead of using 20 seconds, I'm going to use 1/3 of a minute. Just because I'm going to leave everything in minutes. If I change everything to seconds, that would be different. But this means my period is 6 pi minutes. Okay? Let's talk about D. That's the next easiest thing to figure out.
Okay.
Well, if this water wheel was at the origin, it would look like that. And D would be 0. But it doesn't look like that. It looks like this. Where
Right.
this thing, water, is 8 feet above the x-axis. So D is 8.
Okay.
In other words, if D was 0, this thing would look like that. But it doesn't. It's up above the origin and the water. Remember, it's a water wheel. It picks up water, turns it around in a circle like a Ferris wheel. Now, the only thing we haven't figured out is C. In other words, so far we have y equals 14 sine of 6 pi x plus 8. That's if there's no phase shift. Well, let's read the rest of the problem. So it says 2 seconds after you start,
Yeah.
the woman is at the top. The woman that you're torturing is at the top of the wheel. So she's up here. So the height, which at this point in time is equal to 14 times sine, okay, we'll leave it in minutes. I can translate 2 seconds to minutes. I should have left it in seconds to begin with. Let's go back, leave it in seconds. It was 20 seconds. That's pi over 10. So that's our function, and everything's in seconds now. Okay, so it's 14 sine pi over 10 times t, where t is in seconds, plus 8. That's our equation. Minus c. There might be some phase shift here. And we're going to be able to solve for it by taking this additional information. At the end of 2 seconds, this thing is at a maximum. She is at the top.
Okay.
So that tells me that, well, first of all, tells me that that part of it right there has to equal what?
So
1 is the maximum that a sine function can ever be. -1 is the smallest that it can ever be. So I'm going to set the sine of pi over 10 times t minus c to be equal to 1. Remember, y is the height of that lady at any point in time. So she's only going to be at the top when C is a specific number. Well, if I say the sine of pi over 10 times t minus c has to equal 1, well, that tells me that that has to equal pi over 2. In other words, pi over 10 times t minus c has to equal pi over 2, because that's where sine is equal to 1. So I get 1/5 t minus c equals 1. Can't solve that. I guess they're telling us that the phase shift is 0. In other words, we haven't really encountered a problem yet where the phase shift is not 0.
Okay.
A phase shift of something other than 0 would be like that. Notice that does not start at the origin. It starts right there.
Right.
So the phase shift would be negative, whatever that distance is. Okay? And a better example than a water wheel would be, I won't take up any more of your time, but if you had a Ferris wheel. Let me just point this out because I think it'll help in your understanding of it by a lot. If you had a Ferris wheel like that, okay, and you had everybody getting on, they had to climb up these stairs. So the person getting on is getting on right there. That's your phase shift right there. If they're getting on right there, there's no phase shift. If they're getting on right there, there's no phase shift. If they're getting on right there or right there, there's no phase shift. But if they're getting on somewhere in between, then there's a phase shift. Now, that's all I'm going to say because it's not clear to me that you've even had phase shift at this point. These problems are already 10 times harder than they should be for your class. I don't know what else to say. Okay? So, Dimitri, I will let you go, and I will talk to you Thursday at 7.
Okay. All right. Bye.